I'm Agnes. I'm the organizer for this event, and I recently completed my PhD in our uni in PhD in statistics, and also for my undergraduate, I also did my bachelor degree here in mathematics and statistics. So when I was a student, I always have that kind of questions: are the courses that we're taking actually useful for us? Are the research skills, like those technical skills that we all learned, the critical thinking skills, are they actually useful in the mind of the industrial people? So with all these questions in mind, I think it will be very valuable if we have someone here, someone from the industry to share her experiences and advice. And let's welcome Dr. Anjali Gupta.
Hi, everyone. I'm Anjali. I am here to talk about the data science journey and the essential skills required to have a successful career in this field. The main message of today is tools change, fundamentals last. So a little bit about me before I delve into the field of data science, which is quite dynamically changing. I am from India. I studied in Delhi until my bachelor's, and I did my bachelor's in statistics. It was a little bit more theoretical, so I got very good foundations of this field. But after I completed my bachelor's at University of Delhi, I wanted to do a bit more applied work. I wanted to actually work with the real data. I wanted to see what kind of challenges are there when you start looking at real data rather than the traditional textbook data, which may be very clean. And clean data doesn't exist in the industry. There is nothing known as clean data. Anybody who says our data is very clean, they probably haven't looked at it. So I wanted to do a bit more applied work, and I went to Oxford University for my master's in applied statistics. When I completed this master's, this postgraduate degree, I thought I'll never do a PhD. That was my thing, and I wanted to go to industry and work for a bit. I worked in the industry for a bit, but here I am. I actually ended up doing PhD in forensic statistics here at Oxford University in the stats department with Professor James Curran. And that was a very, very memorable experience. I really enjoyed the research. I also learned a lot of skills that are very critical even for the industry. I think a lot of the times the questions are, if I'm doing PhD research, is it relevant to the industry or not? It is very much relevant, and we'll talk about it today. And I've definitely transitioned between industry and academia a lot in the last few years. So I've utilized my skills, and I can talk about it today. My journey has been all over the place, I guess. I have worked in very different sectors. I have about 13 years of work experience, in which I have worked in energy sector, where I worked as a statistician. That was my first full-time job after I completed my postgraduate degree. It was a company which was a startup. So it was in total 10 people when I joined. And I got an opportunity to do end-to-end work. It wasn't just me sitting and working with the data. It was actually thinking end-to-end workflow. What is the question we are trying to solve? Why are we trying to solve it? What do we need to solve that question? What's the impact of this question when we actually solve? How is it going to help? And from there, all of the work that we learn in the field of statistics, in the field of data science during the university, and then towards the end, it doesn't end by just having predictions. It doesn't end when you get some results from a model. You then have to think about how you're going to tie it back to actually help somebody make decisions. How is it going to tie back with whatever the problem you were trying to solve at the very start? It doesn't end that I have got a statistical model or a data science model and I've got some outputs and that's it. It just doesn't end. We need to help the business take decisions from that. If we don't help, they're going to take those decisions anyway. But because we have worked with that data, we have built the model, we probably know more about it than somebody else who's just looking at some numbers, some output. So that's what I got to do in my first job, which is actually very different, because usually when you start working in industry, you're not usually joining a startup. It's a very well-established company and you get to work on one aspect. But if you get a chance to work in a startup where you're exposed to end-to-end work, that's a very good experience to have. I worked in that company for a couple of years. and then moved to finance. Finance was a very different experience. It was credit scoring work. So I ended up using logistic regression there. It's essentially logistic regression, but if you search online on Google what kind of models they use, they'll probably use some other terms for it. But essentially, it's all statistics in the background. I worked there for a year and I felt I was stagnating. So ended up coming to New Zealand and did a PhD here. After completing my PhD, I went back to the industry and worked in marketing as a senior data scientist. The problems that we work in marketing are some things that have already been solved. So it's not very innovative, but it's actually a good experience to just practice some of the things you might learn in the university. So I worked in marketing for a year, and after that, I went to academia. I went to Australia and worked as lecturer for 3 years in University of Technology, Sydney. Working in Sydney, I realized I wanted to come back to New Zealand. New Zealand is quite peaceful. So made the move back, and now I'm working in a company called Oratain. I'm head of data science there. I've been in the company for over 2 years, and the company does very interesting work. At least I find it very interesting, and I hope you will too. They do origin verification work. So if you're wearing a cotton shirt, do you know the origin of cotton? Where is the cotton from? And we don't rely on paperwork. You can say that, yes, there must be paperwork. Whichever company is manufacturing that shirt, they must have the paperwork. But paperwork can be changed, right? There are all sorts of things. The labels can be changed. Paperwork can be changed. What can't change is actually the properties of that cotton, which is used in that garment. So you can send that cotton to the lab. You get some analysis, some chemical analysis, and compare that with the baseline, with the reference data that you might have created for that region or for all of the regions. You might have mapped that cotton for the whole world. You can compare that and try and figure out where that cotton is from. So that's what origin verification is. Our company does that, and it helps other organizations, other clients of our companies that may have other traceability softwares. They might be doing all of the paperwork themselves, but they still need some sort of evidence. If they are acquiring cotton from somewhere in the world, they need to know that whatever paperwork is being sent to them is actually true. Whatever somebody's claiming is true, is holding up. So that's what Oratain does, and that's where I work. The company was founded in 2008. It's a New Zealand-based company. It started in Dunedin by Professor Russell Frew. He was one of the founders, and he's still in the company. We have a team of 9 data scientists split across New Zealand and UK. And Agnes is one of our newest hires. She joined us in the month of March. Very good hire. Very happy with her. And all of our team has very specific emphasis on statistics. We have all sorts of roles, but we really focus on hiring people who have very strong foundation in statistics. Obviously, every company is different. You don't need the same level of skill set in every field for every company, but there are certain companies for whom you absolutely need that strong foundation. So why should you care about data science? I mean, you're here, I'm assuming you're interested in the field, but why should you really care? Data science is an interdisciplinary field, and the benefit of being in this field is you can actually work in any domain. You can work in finance, healthcare, technology, marketing, anything. In my own journey, I have worked in 5 different domains until now in 13 years that I've been working. And I don't know about future. It's not necessary I'll stick in the same domain. I might change again. It offers you the flexibility as long as you're willing to learn the new domain. You obviously need to learn the new domain, but your foundation stays the same. Your ability to analyze data, to fit some sort of models does not change. There is an exploding demand for problem solvers, not just coders. With AI coming in the picture, we have a lot of assistants available. We can utilize a lot of these tools to make our coding faster. But you can't necessarily do that for any problem solving. You still need to work with domain experts. You still need to understand what you're trying to do. So you can't throw all of that into a platform like ChatGPT, all of these platforms that are exploding in today's world. So there is quite a big demand of problem solvers, not just coders. Data science is definitely not coding. Data science is a lot more than that. Coding is a tool. Coding is something we use to do our job, but it's not the job. The job description is much wider. So this field really requires very strong foundations. And what are those foundations? There are three main pillars here: mathematics and statistics, computer science, and domain knowledge. The intersection of these three fields is data science. Each of these three is very much critical to be a successful data scientist, but the industry you pick, the domain you pick, that will determine to what level you need to know each and every other field. So it may be that certain fields do not require that strong foundation of mathematics, but then they may require more of computer science. There will be other fields where it's the opposite. Marketing is a typical example. I worked in marketing, and although there was a bit of statistics, it definitely wasn't as intensive as what it is in auditing. But having the foundations, the right foundations, gives you that ability to try different fields and to actually succeed in all of those fields. And the day-to-day job of a data scientist actually stays the same, no matter what domain you go into. For us, the day-to-day job is you start with the problem. You start with what is the problem we are trying to solve. You coordinate with the collaborators, talk to them, stakeholders. If they want you to solve a problem, you need to understand why. You have to have that curiosity in your mind. Why are we trying to solve, rather than just taking the problem and throwing some data at some model? It doesn't work. You need to understand why we are trying to do something. What is it actually going to do? What's the impact of this work? Because that's when you can think about all of the data sources that might be available. Maybe it's publicly available data, maybe it's not. Maybe you have to acquire it from somewhere. You also have to think about feature engineering. Do you need to transform some variables? Do you need to create some new variables from the existing information? You need to think about what kind of statistical models might fit to that kind of problem you're trying to solve. It's not helpful to have a data set and have 30 odd models and throw your data at it and see what gives you good results. It doesn't work because it's only going to create a lot of noise. At the end of the day, you will have no idea if a model is working well, why. So you need to really understand what you're trying to do, because that will give you a very good indication of what kind of models might work well and why you're trying to do it. You'll have a very good justification for yourself, and you can explain that to somebody who's non-technical as well. You use that model, which also means because you've understood all of the context around it, you can then interpret the answers very well. You can create visualizations, you can create presentations for non-technical audience. End of the day, in any job that you do, you have to ensure that whatever you are doing is translated back to business decisions. That's the end goal. You have to ensure that it is all tying back. It's like a loop. It has to go back to the business because that's where the problem started. So essentially, when you complete your exercise, it should feed back into that and should solve some problem. Otherwise, whatever the exercise is, it makes no sense if it doesn't solve anything. So for us, day-to-day job is really end-to-end. That's what we focus on. We never start our job with, this is the data and this is the model. So I'll talk about a bit more into the kinds of things I have actually used in my job. The pillar one is mathematics and statistics. So I mentioned briefly that I worked in energy sector in my first job. And there, the problem was to forecast the electricity demand in short term, medium term, and long term. You can imagine the number of factors that can impact electricity in a city. We were trying to forecast electricity at every 15 minutes interval for the following day. So sitting today, I wanted forecast for tomorrow at every 15 minutes intervals, so that the distributors can actually plan how much they need to acquire from wherever. There were a lot of factors at play. Seasonality plays a very big role. In winters, you expect a different demand. In summers, you expect different electricity demand. Festivals, weekends, the demand of previous week, the demand of previous year. So there were a lot of factors at play there. We ended up using generalized additive models. Imagine if there was no strong foundation of statistics, we would have had no idea what model to use. We would have tried to do some sort of prediction, but it would not have worked. By using a good foundational model, our error rates for the distributors, they were actually claiming 20% error rate. It went down to less than 5% by using these models. So they ended up saving a whole lot of money. That was my first exposure to a job where I used real statistics, and that was my first job. So it gave me a really good idea of what industry might be like. The second one, which I'm going to talk about, is Oratain, where I work currently. It's very heavily statistical work that we do. We use Bayes' theorem on a regular basis, density estimation, non-parametric methods, of course, hypothesis testing, that's everywhere. The other very interesting aspect that we focus on is geospatial statistics. It is basically using geospatial data, latitude, longitude information, and statistical models together. All of that in one. And we use experimental design as well. So these are just few of the important things we use, but this is not the extensive list. We use quite a bit of statistics in our work day to day, every single day, with no exceptions. So you can see how statistics and mathematics can actually help you in your different jobs. It is not something that can be learned in one course while working. It's something you need to have a very good foundation of. You can learn coding. You can pick up different tools while you're working in a company, and different companies focus on different tools, whatever is applicable to them. Like finance will have their own set of tools. FICO is a product. There are lots of products that they specifically tailor for finance industry. There's SECS, there's SPSS, there's freely available tools like R and Python. There's no limit to it. But it doesn't mean that if you learn one, you cannot learn the other. It's relatively easy to pick up tools, but it's very hard to pick up the right foundations later. The second pillar of computer science, again, a very important one. Data scientists never work in isolation. They will always work alongside data engineers, software developers, because when you're doing any data science work, you need to tie back to the databases. That's where data engineers come in. When you finish your work, you probably need a way of front-end development. We can do it ourselves, but then we have an expertise. We have expertise in mathematics, statistics, or data science. And companies usually have software developers. So we collaborate with them a lot to do the front-end development, which is where having background in computer science really helps, because then you can collaborate well with them. They speak your language, you understand their language. It also gives you a little bit of engineering mindset. It gives you an idea about version control, which is very common, very heavily used in industry, so that you can go back to any version. If something fails in the next few versions, you lose the code, anything happens, you have to have version control. You also need to learn about modular code. It makes debugging a whole lot easier. Imagine having a script of 1,000 lines versus a modular code where there are multiple scripts, smaller scripts, which are a lot more manageable, and you can test them individually. So having a background in computer science gives you that exposure to how data engineers, software engineers might think. You also need to learn a bit about algorithms, efficiencies, like the sorting algorithm, the searching algorithms, because these things you can do as a person in statistics, but also there are a lot of things that you can target in a much better way if you have a background in computer science. Data structures are really important, no matter what language you use for coding, whether it is R, Python. Arrays are very commonly used, vectors, tabular data formats, graphs, trees. So having a bit of background in all of these really help. The third one, very important, domain knowledge. Nothing exists without this. No matter what field you work in, everything starts from the very beginning. What's the problem you're trying to solve? If you don't understand the domain you're working in, it is almost impossible to define the problem. If the problem is ill-defined, everything else makes no sense. So it's really important to focus on domain knowledge, whichever domain you work in, whether it is finance, marketing, You need to be able to talk in the language with the people whom you're collaborating with. Biostatistics is a field where you need to understand how the tests are done with the placebos. If a new drug is coming out, you need to understand the language of patients, disease control, drugs. Only if you understand the domain, you can define the problem, which will then lead to every other successful step in your data science problem, whatever you're trying to solve. You'll have a better understanding of the kinds of variables to use, where to expect correlation in the data, how to do feature engineering, what statistical model to use. Once you have the results, how do you interpret all of those results? That will be a lot better if you have the domain knowledge. And at the end of the day, when you want to help the business take decisions from your work, it will only happen if you understand the problem in the first instance and how you then help them to take decisions. Otherwise, a statistical model or a machine learning model will just be sitting there in a computer unused because nobody will know what to do with the outputs. So very important aspect, without which it's very hard to solve any problem in a very impactful, valuable way. For all of this, you need to have a foundation first mindset. See the tools as enablers. Tools are not the goal. Tools like R, Python, Jupyter Hub, QGIS, everything. These are all replaceable. Today we have something, tomorrow we'll have something else. It's important to master one so that you can pick up the second one or the third one, whichever company you go to. Tools change. Every company has their own tech stack. It's not stable. But the foundation doesn't change. Your basics of mathematics, statistics, computer science, they will not change. They stay the same. So if you have a very strong foundation of the basics, then you can pick up anything. There's no stopping. Concepts outlast technologies. So today, there is a lot of movement towards Python. I personally prefer R for a lot of things, but doesn't mean I can't work with Python. I've picked up Python along the way and I can work with that. Tomorrow, if something else comes up, yes, I can learn that. These days, there are so many tools, Databricks, Snowflake, everything, but it's not hard to pick up a tool. And I haven't seen a company that will say no to a candidate who doesn't know a tool, but they can say no to a person who doesn't know the foundation. Having strong foundations will definitely help you build your own confidence. You'll know what you're talking about, how to solve a particular problem. And it'll give you the capability to actually change industry if you want to. If you want to work in different industries and experience and you want to figure out what you actually like, it'll give you the ability to do it. If you stick with a particular tech stack and that's your focus, then you'll be stuck in a separate category of companies that only use that tech stack. You can't move around. So you can see all of the different technologies that are available these days, and this is not exhaustive in any way. I'm sure there is a lot more available. There is no way anybody can focus on every single thing while they're at university or even while they're working. And I know I haven't worked with everything that's here, but I know if I have to pick up something tomorrow, I can. Python, R, SQL, Spark, everything. These are the means to apply your fundamental knowledge. So learn one tool well, but focus on the mastery of your foundation. That's the main objective. As a student, as a person who's starting their career, focus on the right foundations. Tools are enablers, not the goal. And remember the basics. Basics are what matters everywhere. The problem on the surface might feel very complicated, might look very complicated, but when you actually dig through what the problem is, what the data is, you'll figure out that it's all the basic concept of statistics applied in a very different way. So a few examples here. If you want to predict house prices, you will have lots of variables. You'll have variables like the area, the country, the economy of the country. But at the end of the day, you're trying to use regression to predict prices of the houses. So it's regression problem. Fraud detection. very common in finance, but essentially it's logistic regression. I was actually asked this question in one of my interviews when I interviewed for the finance company where I worked. They asked me what statistical method you would use to actually detect fraud. All they were expecting from me was to say logistic regression. The third one is when you want to work in medicine field, you want to compare a new drug with a placebo, what do? Experimental design, it's very, very crucial in that aspect. You need to know how the experiment has been designed. There is no bias in the data that you're collecting, and hypothesis testing is the base there. There is a lot of, like if you Google how Netflix actually recommends different programs or movies to you, there are a lot of recommendation systems. You dig through that, these algorithms are using similarity measures like Euclidean distance. They may be using some other metrics, but it's essentially the basics of statistics. So if you know the foundation, everything else just layers up, it all builds up. You don't have to learn everything. You don't have to learn all of the recommendation systems. Have the right foundation because that will give you an idea of what might work. And also if something doesn't work, it'll give you the ability to debug that. It'll give you the ability to understand, okay, this is not working. Why is this not working? If you don't have the foundation, it's very hard to actually understand when a method doesn't work. So early in the career, and this is my recommendation, obviously, spend 70% of your time on the basics, 30% on the tools. You should focus on building small projects that interest you. There is a lot of data that's available online. There are a lot of websites, freely available data. So you should start experimenting with that. Build small projects that highlight your fundamentals. So when you go in and appear for any interviews, you can talk about those hobby projects. You should definitely look at the third point because it's crucial. Explain models in plain language. We have this a lot in our company in Oratain where the executive leadership will ask us, how would you explain this statistical model in plain language to a non-technical person? And if you can't explain, they basically think that you don't understand what you're talking about, which means you have no idea what problem you're trying to solve and you have no confidence in your results. So you need to have that foundation so you can explain the technical concepts to non-technical audience. It's very important. It is one of the skills which is very hard to master, but once you get the foundation right, once you have your understanding there, then it's the best thing to have. And you should learn by doing. Implement algorithms from scratch. These days, there's so many tools available. They give you the capability of just drag and drop. You can pick whatever algorithm you want and you can throw your data at it. It doesn't help unless you actually do something from the basic. You can pick up, if R is what your tool of preference is at university, you pick up R and actually write that code like linear regression formula. When you do that, you actually think about every aspect, the weights associated with that, every variable, the correlations. It's really important to understand these aspects. Soft skills. These will multiply the impact of your work. And not having soft skills is basically a technical person sitting behind a computer doing the work and stopping there. Always ask the question why. When somebody gives you a problem, ask why. What is the impact of this? If your statistical model doesn't work, you need to ask yourself the question why and talk to the stakeholders why they think it doesn't work. Because then that's what is going to give you the information how you can improve upon your work. Storytelling is quite important. Turn everything, all your numbers into insights, into the message that you want others to take. That's how they will remember the message. If you just give them an Excel worksheet with some numbers, they have no idea what to make of it. And a lot of the times, the leadership of a company doesn't have time to actually analyze your numbers. So you should never stop at just predictions. Always do some visualizations, some insights towards the end of it that clearly tells them what message you want to deliver. Collaboration. Nothing works in the industry without collaboration, and I guess academia as well. Collaboration is quite critical everywhere. You have to work across teams, across different fields. because you're always collaborating with people from whichever field you're working in, whether it is finance, energy sector, whatever it is. You have to also collaborate with software developers, data engineers. So there's no going around this. And always stay hungry to learn more. There will be new tools coming up. There'll be new developments in the field of statistics. Always be open about it. You'll have to continue to learn in this field. So a roadmap for you. The first one is foundational. Mathematics, statistics, and computer science. Focus on these as much as you can. Pick one tool to practice. It can be anything that you like. It could even be SPSS, SAS, whatever it is, whatever you're comfortable with. But pick one tool and practice everything that you can. Build a few projects from freely available data sets or any other data set that you can get hold of. Try out things in that. It'll give you some insights, some learnings, the challenges that you might face by working with some kind of data. Try and find some internships and mentors. Internships exist in industry and they help you, they give you the exposure that you need. And when you apply for jobs, then you can actually say that you interned in a company. It shows something extra on your profile that you've taken some initiative. And think about specialization later. Everything comes later, like natural language processing or any domain-specific specialization you want to do, everything is later. The basic is foundation. The future, there is a lot of talk about artificial intelligence. It is going to help data science field as well. We can't sit back and say AI is not coming there. It's out there and people are using it. It's the way you use it. If you use it as a tool for you, which helps speed up your work, it's very helpful. If you try and throw everything at AI and expect it to do your job entirely, then that's where the mistake is. Because AI is very good at a lot of things, but it also gives vague answers to a lot of questions that you ask. It doesn't understand the entire context of the problem. A lot of the times you can't even give everything to AI platforms because data is confidential. You can't use these kinds of platforms to solve all of your problems. So AI can definitely help data scientists in automating some of the more trivial tasks. But wherever the main crux is, like talking to the stakeholders, understanding the concept, the why, what models you want to use, what is more appropriate for a particular kind of problem, that still requires humans. And that's where the fundamental knowledge is important. So we need to treat AI, auto ML, all of these tools as tools that will help us do our job, but not our job. Explainable AI and responsible AI need rigor and clarity. Explainable AI is more around the ability to explain whatever statistical model, machine learning model, or AI that you're using. Like you need to understand what it is actually doing. Responsible AI is a very interesting one. A lot of the times we don't think before using some particular tool to do a task, but when you actually think about it, you realize it's not ethical to do it. It's not a responsible practice. I can give an example. When we go to supermarket like New World, we order some groceries, we go home and we start getting emails from them for recommendations. And we treat it as a normal practice that yes, they are looking at our purchase history and what people are buying else, and they're suggesting some things. Imagine if pharmacists started doing that. You buy some medications and then they're sending you emails about, oh, people like you who bought these medicines, they also bought these other medicines. That's where you start thinking what's happening in the world. So it's very important to always think about AI, everything that you do in a very responsible and ethical way. Should we be doing it? Are we utilizing some personal data for some other gains that we shouldn't be doing? So always have that in your mind when you when you solve any problem, when you try to work on any data set. So the key takeaways today are don't chase tools, chase understanding. Foundation has to be correct no matter what. So strong fundamentals will lead to long-term career insurance. Right now, there's a lot of uncertainty in the industry, what's going to happen to people's jobs with AI coming in. But if you have strong fundamentals, you do not have to worry. Start small, stay consistent, and build your confidence. Start with very small projects, try to solve them, see where you go, what kind of problems you face, or the learnings that you get from them. The basics are the core here. If you have them, that's your superpower. Your journey is unique, crafted intentionally. Questions?
Thank you, Anjali. So yeah, anyone have any questions? Anything about your study or your career path or anything?
Hey, Anjali, it's good to see you back at University of Auckland.
Very nice to be back here.
Thank you for bursting the brain drain. Yeah, I see your sentiment about the foundation being important, but I do think that a lot of students, they just want to go straight into using the tools.
Yes.
Data science. And I find it really frustrating. I have a very specific area of research, it's fisheries, but we have lots of binary data and it's like just models for Africa. And I can throw a mix of different models and all sorts of cool stuff and games and things like this. And I just can't get people interested in that. I just think, well, you learn this and then it's transferable to other areas, but the methods is somehow getting lost. And it's very frustrating when a lot of students that want to do data science, the computer science lecturer get overwhelmed with students applying for projects and they don't seem to be interested in a sort of specific area that I work in. Now, I'm not a buddy, I know that, but it's interesting to see that students unfortunately aren't listening to this message as much as they should.
We've seen that even in the recruitments we have done recently. We got hundreds of applications, but there were very few applications where we could see that people had very good foundation of statistics. That's where we figured that there is a gap. And I think there's a lot of noise in this field right now because there are so many tools. And if anybody searches on Google, what is data science? The foundations actually don't even come up first. It's all the tools, everything about tools. That's where the problem is, I think. And that's why I feel that it's become even more important to make it very clear, I think, to anybody who's joining university in the field or anything, and to re-emphasize this message that actually it's the foundation that matters. It's not the tool. Tool is just, if the topic interests a person, I think that's what is more important. And the core of statistics is more important than anything.
Yeah. The AI will eventually learn how to drive itself when it comes to these implementing tools.
Yes. Yes. And that's where I see AI as a tool which will speed up our work. Sure. It will probably lead to more efficiencies, but it will not, the way I see it is, it's actually going to drive us towards the more strategic work. We are going to think more about the problems we're trying to solve and how it's actually going to help the business or wherever it is, whatever we're trying to do, rather than doing some of the more trivial things, which AI can do. AI can automate a lot of things today, and it'll only get better. But without having that thinking, that domain knowledge and the right statistics foundation, I think it's very hard. It's going to be very difficult for people to have that stable career in the field.
Your jobs that you've been in and where you're currently in, you seem to have fairly specific questions of interest, and it's quite related to your forensics background and change what you're doing right now. It's really cool. I guess in data science, a lot of it is just get a whole lot of data, tell me something about it. Where they perhaps don't need the foundations.
Yes. And that's where I think the fields like marketing, they're very different. Marketing definitely doesn't need as much. It's a very general, I want to create personas of customers so I can target them in a separate way. So it's a simple clustering exercise there. So there are a lot of those fields as well. So everything exists in the market, depending on what a person needs. There is different proportion of that statistics that will be used in their day-to-day job. Maybe it's very less, maybe it's a lot more. But definitely the kinds of jobs I've done, except for maybe the marketing one, everything had very heavy emphasis on statistics. It may even be that I was unintentionally looking for it, being from the field of statistics, but I definitely came across more such jobs than not.
May I ask what kind of subject are you guys studying? Amazing.
We're doing TFC, the foundation course
Oh,
at UOA.
oh, okay.
Yeah,
So it's
but our lecturer just told us about this.
foundation course is, sorry, so it's like general.
Yeah, it's basically just like it's like basically like year one papers, but lower. That makes sense. So for people that have maybe been out of school for a long time or not completed high school.
Yeah.
And my statistics lecturer was telling us this. You have a QR code to sign up for that, so looks interesting. So
You guys are interested in studying?
what we're studying right now.
Yeah.
I'm doing mathematics, statistics,
Because I also study math here, actually I do pure math. But I actually found that recently in my job, I also apply lots of pure math stuff, even though people say pure math, you don't apply them. But actually lots of them is very relevant. Things like, just basic linear algebra, project the basis. All this thing actually later on actually in your job, at some point you find out, oh, actually I can use it. Actually it's very useful. You would never know. So I'm very glad that I studied offline again. I do think I built quite a good foundation here in whole so-called the next generation for the student here can also get the message that it is very important. So and we want to also take some questions from our online audience. Is there any questions?
Haven't seen anything.
Pascal, are you on? I move this one.
Oh,
there's
there are a
some.
few.
So there's one question here. How? So we got applied data science and applied computing.
I think somebody's
okay, there's one question.
Okay, so there's a question. How can you stand out when applying for internships in data science? Interesting question. So when people apply for internships, of course, if there are 5 applicants, all the 5 will have very similar background. Like they'll be probably out of university or still doing a course. The way you can stand out when applying for internships is by actually doing some of your projects yourself while doing your courses. There are a lot of data sets available online. So if you look at those data sets and you try to do something on your own, it shows that you're curious and you want to learn. And then you can show that during the conversation, during the interview, or even write a brief about it in your CV. That will make you stand out. Anything that you can do which is outside of university on your own, which shows your keenness to learn and do things on your own. I think that's what leads to successful applicants. And also the other thing is the ability, if you actually ask questions like, why are we trying to solve this problem in this business? You're trying to understand that. That shows a different level of engagement, more than just what are the kind of statistics you use. We want people who can actually think end to end, even if it is at the level of internship. It will make you stand out just to ask that one question. I hope that answers the question. Christina?
Okay, the next question is, what is the most challenging thing you have encountered in this field?
Recruitment. Very challenging to recruit in this field. Because, the point that you made, Russell, we get so many applications. There is a lot of interest in the field, but the issue is when you encounter a company like Oratain or anybody who's really looking for very strong foundations, we don't find them that easily. Especially in New Zealand, it's a very small country. We don't have as many universities, few universities. So it's very important for us to maintain, good statistics foundation when we are studying. I think recruitment is the most challenging thing I've done.
Paid salary fee?
I would like to think so, but Agnes can probably attest to that. I like to think so. Yes, or
Yeah,
Retain
I think
does well.
it's quite good.
Yeah, it's competitive.
Yeah.
Yeah. Okay, so there's a question from Ben.
Yeah, I'm a data science student. May I know how is New Zealand development status of cloud-based data science or analytics? As like AWS, Azure, and GCP.
I'm not sure what it means by New Zealand development status.
I guess do we use a lot of
Oh,
I
okay.
think in industry,
Oh,
probably that's the question.
Yeah,
We do
we
use-
use cloud-based data science. I think there's no going around it. We can do all of our research, all of our development work on local machine, but when you have to go towards production, you want a system where it can scale up, scale down based on the requirement. So you have to have that entire pipeline in a cloud-based environment that will make it easy for you to manage the upstream and downstream. So definitely something which is used a lot. We use Azure at Oratain right now. And also moving towards, we're exploring some other platforms at this stage if something else will help us better.
Do you use AI to filter the app?
No, we don't.
applicants?
No, we don't. I have looked at every single application that has come through to Oratain for any data science role, whether it is 200 applications or 300. I have not used AI so far. I do know that AI is good for certain things, but a lot of the times it can also filter out applications that are genuinely good. So I have looked at every single application. So I do not, I would not trust AI just yet for filtering the applicants. And applicants put in a lot of effort to fill in the application, so I think it's not justified. I'm someone with background in physics. What would help me move towards working at an intersection of it and data science in New Zealand?
We do have someone, yeah.
We have a couple of physicists who have transitioned to data science in the company. And I think the places where they stand out are their mathematical skills, because physics, you do a lot of mathematics as well, and their own interests. So if you're interested in the field of data science, I think it would really help if you took some courses of statistics and you figured out what you're interested in. Some people are very interested in visualization aspect. Some people do a lot of front-end development, so they go on to the other side of data science, which is more about even machine learning operational, MLOps, which is a very common term. It's to create that entire pipeline of machine learning. So there are a lot of dimensions of data science. And as a person in physics, you can still do a lot depending on the path you want to take. And you could always obviously do more of statistics. Nothing is stopping you. You would still have the mathematics skills there.
I have IT background and will soon complete a data science course. Would you suggest me to take up some mathematics study or to strengthen my foundation?
Yes, and statistics as well. Definitely mathematics and statistics. Without it, I think a data science job can be very challenging. Even in a field like marketing, you still need some amount of mathematics and statistics, even if not to the same extent.
Yeah, I think the math that I found that is quite helpful for stats will be linear algebra. Like anything about vector, that's very, because when you're doing all the computing, everything is about vector. Those things are very important. So when you're doing math, even though you probably say, oh, probably I don't want to be a mathematician later on, but those things will help you to understand stats in a later stage. And then another thing would be some like probability. In math, then analysis will help for that one, like real analysis. So those things I found is very helpful for the study in statistics. And from your experience, what are the fields that need data scientists the most?
Oh, any field, anywhere where data is there. That's the answer. Wherever data is there, data scientists are needed. There have been a lot of jobs of biostatisticians in the past, like the field of medicine. Finance sector is filled with data. They need a lot of data scientists, statisticians. But I think any field that interests you, I've seen all sorts of fields. I never thought forensic science needed statisticians, but here we are. And it's quite a good, very interesting field, very different field, but I absolutely love it. So I think whatever interests you, you can always find, like if there's data in it, you need data scientist.
Any questions? Okay, thank you so much for joining us. And here's our organization. So if you want to join for any future events, please follow us.